What's up friends? In this video we're going to be building a DIY 10S 5P battery for the $500 electric Mountainboard kit.
Make my heart beat super fast.
Alright guys, welcome back to the channel. If you're new here, thanks for stopping by. As you might be able to tell, this is a brand new setup and I'm really excited to start working on this. Battery building is one of the more complicated things in DIY e-skate, and it's something that discourages a lot of people from building their own. But I'm here to tell you it might not be as difficult as you think. Before we get started, I'd like to offer a quick warning about battery building. Lithium-ion and lithium polymer batteries can pose significant risk to the user when improperly handled. If you short circuit or overheat or improperly solder or improperly weld them, you can end up with fireball, and we want to do our best to prevent that. If you have any questions about the safety hazards or anything about battery building, there's lots of professional engineers and people who know what they're doing on the eSkate forum, so feel free to give us a shout or ask questions down in the comments below. Safety warning out of the way, let's get on to some basic terminology. One thing that's really important to know when you start building a pack is the concept of series and parallel cells. But before that, I'll give you a basic overview of electricity. You can think of electricity as water in a pipe, where the voltage is the water pressure and the amperage is the diameter of the pipe. So if you think about a battery or a 12S battery that can push 100 amps out, your diameter of your pipe is 100 amps and your voltage is 50 volts, which is what 12S is. For these lithium ion cells that I'll be using in this pack, they go through an interesting discharge curve. For charging them up, these are only allowed to charge up to 4.2 volts per cell. And when discharging, technically the lowest you can go is 2.6 volts, but most of the voltage range in there is not very usable. So for my packs, I like to cut off the voltage at about 3.2 volts per cell. Now, obviously, 3.2 volts is not going to get you very far with speed controllers that require 36 volts and above. So now comes the concept of series and parallel. When you hear people talking about electric skateboarding packs, you might hear them say, oh, this skateboard has a 12S 7P battery, or this skateboard has a 10S 2P battery. It's not super great. What does that actually mean? So when we're building our electric skateboard packs, our goal is to provide the perfect amount of energy to the speed controller in order to get the most zoom for the least amount of weight. And obviously another thing to consider is range. That's based on the capacity of the cell, and we're not going to get much into that today. But back to the idea of series and parallel. So when you put two cells in series, you're essentially lining up the positive of one cell to the negative of another cell. And I can actually grab two right now to demonstrate. So on this 18650 cell, you have a positive and negative terminal, and it's the same for the other. So when you put cells in series, you put the positive of one cell to the negative of the next cell, and now if you measure the voltage across from one end to the other, you'll get the amount of voltage from this cell and the amount of voltage from this cell added together. Now when you put cells in parallel, you're doing it a little bit differently. The positives go to the positives and the negatives go to the negatives. So essentially what you're doing is creating one larger cell by combining the capacities of each of these two together. And that's what we'll be doing in our P groups for the electric skateboard. So I said 10S 5P battery, and in that case we're going to be putting 5 of these in parallel, which, skip forward a second here. I have 5 of them glued in parallel, all the positives together, all the negatives together, and then a nickel strip will go across the top and bottom to combine them together. So that's 5 cells in parallel, and then we'll have 10 cells in series, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But it'll be wired in a way that works with my electric skateboard enclosures. With this 10S5P configuration, this pack will deliver more than enough power for what this board is capable of. Next, let's talk about some battery building supplies. First off, we'll obviously need our 50 battery cells. So we have 50 18650s for this build. Next, we'll need something to connect all the cells in parallel. For that, we'll be using nickel. It's readily available, easy to weld, and it's a great conductor. You can also use copper, but it's a lot harder to weld and a little bit harder to source. Next, we'll need something to connect all of the cells in series. For that, we'll be using high strand count silicon insulated copper wire. This is a great option, it's super flexible, and it's really easy to solder. Some of the other things we'll need alongside is some hot glue, a welder, fish paper rings, insulating fish paper to wrap around the cells, some tape, and some other materials. You can see why a lot of people like to leave this up to the professionals. Alright, let's start putting together the pack now. I used black hot glue to connect all the cells together in this particular pack, and I will continue to do that going forwards. It's strong enough and the cells should never heat up enough to actually melt the glue again. You can also use silicone to connect the cells together, but it's messy and it takes a long time to dry. These cells are actually reclaimed 30Q cells, so they have a little bit of wear on them already. I prepped all of them by grinding off the old nickel that was stuck on them with a rotary bit for my Dremel. And this worked really well and allowed me to get a nice smooth surface on both ends of each cell to weld to. It's not always recommended to reuse cells, but I know what I'm doing, and they all have been aged and voltage matched across the entire pack. Additionally, this ESC really won't be asking that much of the cells, so I'm not too worried about it. The next part of building a safe pack is insulating all of the P groups. For this particular pack, I have this fish paper, which I already pre-cut all of it. It's not like a very interesting process. I just used a razor and cut it all to the appropriate size in order to completely surround each of the P groups, just like this. And as you can see, it fits perfectly and insulates all of the sides from any kind of electrical contact. After applying all of the fish paper to the parallel groups, it's time to get welding. And I've actually already pre-cut all of the nickel for this down to nice rounded edges to make sure that it's not going to short out on the edges of the pack. And it's time for a little bit of a welding montage. Alright, so now we've got all of the cells welded together, and it went pretty well. Some of the welds turned out a little bit too hot. If you look closely at some of the B-roll, you can see some of the rings around the actual weld spots are a little bit larger than you would expect on a pack, but you have to really crank up the heat to weld 0.3 millimeter thick nickel, and that's just a byproduct of that. So now we have to connect all the cells together in series. So what I'm going to do is cut down a whole bunch of 12 gauge wire that will go in between each of these parallel packs and essentially finish off the construction of the pack itself. Alright, so I've got all of my wires cut now and I've got them laid out on the pack here, and we've got 4 down each side and then 1 to cross in the middle. So we start from cell 1 to 2 to 3 to 4 to 5, 6, 7, 8, 9, 10. And that connects all of them in series. So these will be put through there and sit in their nice little wire channels after they're soldered to the cells themselves. So the next step is just to solder all of this together, and here's another montage. Alright, so I'm almost done soldering together the entire pack, and I just have the 5 to 6 connection and then the positive and negative leads coming off the end. But there's one thing that I do in between that makes it a lot easier. Every set of P groups is going to get taped together with this fiber tape. So this will create a strong connection between the two sides, and it'll let me solder this last connection a lot easier than it would be otherwise. Now that this is all taped up, I'm going to go ahead and solder the last series connection and the positive and negative lead for the entire pack. So there's a couple things left to do. I've got the battery pack positive and negative soldered on with an XT60 connector. All that's done, but now we have to connect the BMS, which is what will manage the charging of our cells, which is this little guy. This is a DALY BMS with balancing, and each of these wires needs to go to one of the cells. So counting up from this black wire, it'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way down the connector. And these will go directly onto the negative terminals of each cell. And I'll explain a little bit more about that while you watch the voiceover. So after we get the BMS connected to all of the cells, I will next need to connect the charge port to the battery and the BMS. And I'm just going to voice over that too because it's going to be a lot easier. BMS wiring can be a little bit confusing, so here's a diagram to help out. On the diagram, you can see the total positive and total negative. Those are the pack positive and negative. And then the balance wires are the strings. So the first balance wire is first string, which is the cell on the pack negative side, and then you count all the way from there up to 10. I've just soldered the C plus, or the charge plus wire to the battery positive, and normally a good thing to do is to put in a fuse in line with this to make sure that you can't short out the charge port. Unfortunately, the fuses that I had were aluminum or something, so it wasn't able to solder, so I'll have to add one there later. After that, I soldered on all of the balance wires, and it's a little time consuming, but it's not too difficult. Next, one of the final touches is using Kapton tape to secure all of the balance wires. Alright, so we made it to the end of this battery build. It's turned out pretty great. I think the final fit and finish looks really nice, all clean and organized. There's still a few things left to do. I gotta put some padding underneath the cells and glue them in, and then I have to make sure all the balance wires are going to be run safely through these channels, and then I might end up increasing the depth of the wire channels on the outside depending on how much they get squished against the deck. The next thing I need to do is add a neoprene gasket all the way around the outside and across the beams, and then mount it onto the deck. So in the next episode, we're going to be mounting all the inserts into the deck, slapping the enclosure on there, making sure all the wiring is done in the ESC enclosure, and we'll pretty much be finishing the build. Remember, every battery build is different, and every battery build will have its own unique questions. So if you have any questions, put them down in the comments below, or give me a holler on the forums or by my email, and I'll try and help you out the best I can. I hope you guys enjoyed this video. In the next video of this series, we're going to be doing, like I said, finishing the actual build. So it should be pretty exciting. And I'll see you guys next time. Peace out.